In this presentation, I'll describe you three things. First, how to compute the distance between 2 points. 2. How to change degrees to radians and radians to degrees. And 3. How to calculate the coordinates of a point in a circle when the midpoint, radius and the angle are known. So first, the distance between 2 points whose coordinates are known. Let's take 2 points x1, y1 here and x2, y2 here. The way to calculate the distance between these 2 points, this L here length, is quite straightforward application of Pythagorean theorem of right triangles. You can see we have a right triangle in this picture where the length is the hypotenuse of the triangles and the legs are shown here. The length of the legs are simply x1 minus x2 for here and y1 minus y2 here. Now the Pythagorean theorem where the hypotenuse is a square of the sum of the squares of the legs states that this L here is shown in this formula here. So the length of the hypotenuse or length in this triangle is square root of x1 minus x2 to the power 2 and plus y1 minus y2 power 2. This way we can calculate the length. So now let's take the real numbers, how to calculate this one. Here we have 2 points. Point 1 is x10, y4 and the point 2 x minus 4. So now putting these numbers to the equation for L, this is just routine Pythagorean theorem. We got 10 minus 4 power 2 plus 4 minus 4 power 2 and square root of that. Initially square root of 100 is 10. So this is quite straightforward way to calculate the distance between 2 points. Now the second task was to transfer radians to degrees and degrees to radians and back. For this task it's good to remember where the radians got their name. I have here a circle with the radius r. The length of the circle is 2 pi r. 2 times pi times the radius, the length of the radius. Full circle is thus 2 pi. The angle of the full circle is 2 pi. We also know that the full circle angle is 360 degrees. So from these observations we get the coefficient 360 divided by 2 pi or 180 by pi. So how to use this coefficient? It's simple. If you have x-rad angle, the degrees is just x times this coefficient here. And naturally, if you want to get radians from degrees, just divide degrees with the same coefficient, like here. So this is the formula for radians from degrees. Let's give 2 examples with the real numbers before we finish this part. The corner of pipe divided 2 rod is, as calculated here, 90 degrees, so this is a right angle. And then we take an example from the degrees to rod calculation. So here we have 60 degrees, and to calculate how it is in rads is just 60 times pi divided by 180, just like this formula here. So we receive the result is 1/3 of a pi, or if you want to write this out as a decimal approximation, 1.0473. So overall this is quite simple and easy way how to change degrees to rads and rads to degrees. The third topic here to discuss is how to calculate the coordinates of a point in a circle when we do know midpoint, radius and angle. Okay, here we have a circle where we do have a radius here, the theta, which is the angle between the point, the vector to the point. Let's add the point with the clear mark here. Well, if you use green one here, and the midpoint is there. We can start this calculation with the unit circle, where we have defined the radius as 1 for this circle, and the midpoint is here is 0, 0, and the radius is 1. Now the xy coordinates of these points comes from the Pythagorean theorem, where here we have a right triangle, and since we know that the length is 1, then we have this y coordinate here is the relations of this leg here to the hypotenuse, which is cosine of this theta corner angle here. So naturally cosine is the adjacent leg relation to hypotenuse. So we get the x coordinate with cosine. And with sine function we get then the y coordinate. In this unit circle we have midpoint at 0.0 and radius is 1. And once with these parameters we get coordinates of the point as cos sine of theta, sin of theta. So how we to extend this information as a general circle anywhere in the xy coordinates. Let's calculate that one next. When we have r radius different than 1, the length of the radius is multiplied with a constant to receive this radius. And since the sin is in relations, also the length of this leg is multiplied with the constant, and same goes through, of course, naturally with the cosine. So we get the changes for this formula here. We have both coordinates multiplied with the radius. And how to take the midpoint into the effect. Let's say midpoint is x1, y1, or y1. We add these midpoint coordinates to get final formula of the point here.